Hey everyone, we're going to do a little unit circle intro here today. This is kind of part of 4.2 and part of 4.3. We've kind of been hinting at the unit circle for a few days now, and so today we're just going to kind of jump in and at least get some basic values of sine and cosine, and then tomorrow we'll probably go into tangent, cotangent, secant, cosecant, that kind of stuff. So let's jump in. And first thing we're going to do is a little bit of bell work from what we learned yesterday. So I'm going to draw in some figures in here. So let's say this is a 37-degree angle, and the hypotenuse here has a length of 8. And this is, let's call it y, and this guy, let's call it x. So both of these are calculator problems, and if you'd like to give them a shot, feel free. In this one, we just want to find y and x. And this guy over here, we're going to try to find how tall a building is. So if you're standing 340 feet from the base of a building, you look up at a 65-degree angle to see the top. We want to know how tall that building is. So you might want to try to draw a picture of that. So if you want to try these two problems just for a warm-up here, you can pause the video and then come back and we'll do it together. We'll see how you did. All right, so for this first one, what we have to do is we have to realize that we can use sine and cosine to find x and y. So if I do sine of 37 as my reference angle, 37 degrees I should have up there, that's going to be opposite over hypotenuse. That'd be y over 8. So if I want to solve for y, just multiply both sides by 8. So y is 8 times sine of 37. Now on your calculators, you might have to make sure you're in degree mode. There's a button that'll switch you between modes, between degrees and radians. Ask a friend if you need help finding that, but it shouldn't be too tough. And then on their window, it should say DEG for degrees. And when I type into my calculator 8 sine of 37, I get 4.814. So that's my y value. And then my x value, I'm going to use cosine. So cosine of 37 degrees would be adjacent over hypotenuse. That's x over 8. So x is going to be 8 cosine of 37. Just type that in my calculator. 8 cosine of 37 is 6.389. Makes sense that one's a little bit longer because we can see that with the 37-degree angle there, our x is going to be longer. No big deal. All right, the next one, we are standing, here we are, 340 feet from the base of a building. And it says that I look up at an angle of 65 degrees to be able to see the top. And I want to know how tall it is. Let's call it h. So to find h, it looks like I'm going to have to use tangent because the opposite and the adjacent are the ones that are involved. So tangent of 65 will be h over 340. So h would be 340 tangent of 65 degrees. And we just plug that in. So I'm going to do 340 tangent of 65 degrees. And I get 729.132 feet high. So just a little bit of using trig with right triangles, a little SOHCAHTOA, to be able to solve for some values. Not a big deal, not that tough. All right, so let's jump into the unit circle. So when we're trying to deal with the unit circle, really our goal is to be able to solve something like sine of 4 pi over 3. Or cosine of negative, 7 pi over 6. So there are really two pieces to this. The first thing is figure out where we need to go on the circle. We've been talking about that a little bit the last couple days. If we have one of these radian values, we have to be able to get to that spot on the circle. And then after we get to that spot on the circle, we either are evaluating sine or cosine. And we're going to kind of use SOHCAHTOA here, but I'm going to encourage you just to think about that in terms of x and y coordinates. So we're going to kind of talk about that today. So first we'll focus on how we get to the spot that we want to be at. And then we're going to think, which trig function do I want, and which value is that going to give me? So we'll start by focusing on where you need to be on the circle. So we've seen these circles a little bit, and now I'm going to kind of give you the way that I find these values. So we've talked about how you can split the circle up into a different number of pieces. So we've talked about splitting the circle up into 8 pieces. We had the 8 circle. And on the 8 circle, each one of those, so if we have 2 pi, 2 pi, and we divide it into 8 pieces, each one of those, if we reduce that, is worth pi over 4. So this would be 1 pi over 4. I'm actually going to skip this guy. It would be 2 pi over 4, or pi over 2. This would be 3 pi over 4. 4 pi over 4, this would be 5 pi over 4. 6 pi over 4, it's got to be 7 pi over 4. So notice I skipped these two lines. And there's a reason for that. It's because those are also on the 12 circle. If we take 2 pi and divide it into 12 pieces, each one of those pieces is going to be worth pi over 6. And this is going to include those points as well. So I prefer to just use those over here. So this is going to split my circle up into 12 even pieces. Ooh. Each one of those is worth pi over 6. So we're going to have 0 here, then we'll have 1 pi over 6, which can't be reduced. This will be 2 pi over 6, so I'll start just by putting them all in pi over 6. This will be 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. I'll just count into 12 here. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, and then 12 pi over 6 all the way around. But a lot of those can be reduced, so let's do that maybe in red. So 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3, 5 pi over 6 can't be reduced, 6 pi over 6 is pi, 7 pi over 6 can't be reduced, 8 pi over 6 is 4 pi over 3, 9 pi over 6, if we divide by 3, that's 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6 can't be reduced. 12 pi over 6 is 2 pi all the way around. So these values, and I'll put these in as well. So I'll just rewrite these because I want everything in red. 5 pi over 6, this is 7 pi over 6. 11 pi over 6 over here. And 0 here, and then 2 pi. So these red values here are kind of the values that you get when you divide the circle into 12 pieces. These guys here, they would happen right here in between those values and in between these values right there. So they don't play nicely with the 12 because the difference here, this is 30 degrees, and it'll be 15 and 15 and then 30 here. So you can't consider that as an even piece because the pi over 6 here, and then this would be a smaller piece. So to get the next pi over 6, we have to jump to pi over 3. So the way that I actually do this, I'm going to get rid of those red lines there because they're kind of confusing. There we go. So the way I actually make this circle, and those of you that are maybe in band or have done music at some point might appreciate this, I actually use a rhythm to be able to think of this. So that'll be a good slide to go back to and reference to if you ever have trouble finding radian values on the circle. But so I call this the cadence. So a cadence is a word that you use actually when you talk about like drums that are playing for a marching band. And it's actually how I always have done radians. I'm not sure when I started doing this, but it makes sense to me. So what I always do is I first draw in my 45s. Now what I'm going to do is I'm going to change my color back to blue. I'm going to draw in the 12. So one before here and one after, one before and one after, one before and one after, one before and one after. So the first thing I draw in are those 45s. So I'll do those in red. That's just 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And now what I do is I think about this in terms of like a rhythm. So I think you're at 0 right here, and then I count. I go like this. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is exactly what goes in my head when I think about finding these radian values. So what I'm doing here is every time you have these dots, I'm stopping for one of the red lines. So count with me. Here we go. 1, and then we pause because we have that red line. So then we go 2, 3, 4. Notice there are 3 blue lines together. So that's just 2, 3, 4. Then I pause. And then I go 5, 6, 7, 8, 9, 10, 11, 12. So the pausing really helps me to make sure I know exactly where I'm at on the circle. It kind of is like checking my work as I'm going around. So I have 1, that's 1 pi over 6. Then 2, 3, 4, 2 pi over 6, 3 pi over 6, 4 pi over 6. And then I pause again because I hit another red. 5, 6, 7. Then I pause for the 5 pi over 4. Then 8, 9, 10. And then 11, 12. And of course you can reduce those. So if I'm trying to find like sine of 4 pi over 3, the way I think about that is not 4 pi over 3. I think about 8 pi over 6. And then I get to work. So I just draw my circle. You can do this in your head, or you can actually draw the circle. And so I start here and actually go 1, 2, 2, 3, 4, 5, 6, 7, and then 8 gets me right down here. So I know that I'm just short of 270. So 4 pi over 3 is this value right here. It's that 8 pi over 6. So we can go back and check if that's actually where the red value is, and we see it is. So the whole point of this is just, can I get to the right spot on the circle to be able to evaluate that trig function? And we'll talk about how to get that sine value next. But first it's just, can I get to that actual value? So why don't you try it with a couple? Let's have you guys try getting to, I don't know, let's have you try to get to 2 pi over 3. Let's have you try to get to 7 pi over 6. And let's have you do pi over 2. And let's have you do 5 pi over 3. I like that one. Okay, so you want to pause the video and see if you can get to those spots using this kind of cadence method, or however you want to. Why don't you give it a shot and see how you do. All right, so the 2 pi over 3, I think about that as 4 pi over 6. So I'm going to go 1, 2, 3, 4. It's this value right here. So if we were to draw it on the circle, it'd be just past 90 degrees, that value right there. 7 pi over 6. The pi over 6s, I think, are easy because you don't have to worry about reducing. So I'm just going to count to 7. So I'm going to go 1, here we go, this one. 1, 2, 3, 4, 5, 6, 7. 7 pi over 6, right there. Pi over 2, the thing about that over 6, it's 3 pi over 6. 1, 2, 3. It's right at the top of the circle. 5 pi over 3, that's 10 pi over 6. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just beyond 270, right there. So as long as we can get to these spots on the circle, we have step 1 done. Now there's one more little catch. If you have a negative value, or what I'm calling extended values, that means that you're either going in the opposite direction or you have to continue going around the circle. So for a negative value, really it's just as easy, and the same cadence will still work. Red. So we still have these guys written in here. But what happens is, so like, for example, if we had like negative pi over 6. Instead of going in a counterclockwise direction, which is positive, we're going to go in the counterclockwise direction, which is negative. So right here would be negative pi over 6. This guy right here then would be negative pi over 3, negative pi over 2. So all we're doing is going in the opposite direction. So positive takes us counterclockwise, negative takes us clockwise. So we go 1, 2, 3, 4, which would be 2 pi over 3. 5, 6, which would be negative pi, 7, which is negative 7 pi over 6. We got 8, 9, 10, 11, and 12. So 8 would be negative 4 pi over 3, negative 3 pi over 2. This would be negative 5 pi over 3, negative 11 pi over 6, and then negative 2 pi all the way around. 0 starting there. So negative just takes you in the opposite direction. And the pi over 4s work as well. This would be negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, and negative 7 pi over 4. So going negative again, just going down instead of going up. That's the only difference. An extended value, what I mean by that is they might ask you to find something like, let's do like maybe 17 pi over 6, something like that. So notice 17 is just bigger than 2 pi, right? Because 2 pi would be 12 pi over 6. So if you think about it this way, you can start counting and just keep going. But 0's here, 12 pi over 6 is all the way around. Then we would just keep counting. So let's do the cadence starting at the beginning. So go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 pi over 6 would be the same thing as 5 pi over 6. Now there are some tricks with this. You see that the difference between these is 12 pi over 6, because really what you've done is you go to 5 pi over 6, then you come around a full revolution again. That gets you to 17 pi over 6. Negatives work too. Like if we want to do negative, I don't know, 13 pi over 4. So the pi over 4s, remember, are these odd red values that are around the outside. So if we wanted to do that, let's put in our reds. So this is 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. It keeps going. 9 pi over 4, 11 pi over 4, 13 pi over 4. And again, remember, so 2 pi here is going to be 8 pi over 4. So notice that 8 pi over 4, this is also the same place as 5 pi over 4. And they differ by 8 pi over 4, because you're going to 5 pi over 4, and then one full revolution brings you to the same exact spot. And that's all there is to it. So the extended values, you just basically keep going around, and that's all you have to do. Let's have you guys try a couple. So you try negative 7 pi over 3. And let's also have you try 9 pi over 2. Okay, so I would convert those into pi over 6s and then see where they get you. But give those a shot and see where they end up getting you. All right, let's see how you did with that. So negative 7 pi over 3, I would think about that as negative 14 pi over 6. So what I'm going to do is I'm going to go down. So we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pi over 6 right there. So that'd be negative 7 pi over 3. Same spot as positive 5 pi over 3 or negative pi over 3. And then you go another negative 6 pi over 3, which would be 2 pi. Gets you right there. 9 pi over 2, let's see, if we multiply that by 3, gosh, that would be 27 pi over 6, excuse me. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 pi over 6, excuse me, which is 9 pi over 2. Make that 6 a little better. Gets you right to the top of the circle. So you can always just keep counting. You can also try to think about the difference as being 2 pi. I prefer to just keep counting, but it's up to you. Kind of neat. Okay, so after we've found our spot on the circle, the question is, what trig function do we want? So if we have like sine of pi over 6, something like that, it's like, okay, what does that mean? I know where pi over 6 is. It's over here somewhere. But what exactly does it mean to take the sine? Well, check this out. If this is the unit circle, we haven't talked about this really yet, but the definition of the unit circle is that it has a radius of 1. So the coordinates of this point right here are 1, 0. And so if we think of any angle here on the unit circle, let's say this one right here, theta. Okay, it kind of looks like pi over 3, but maybe it isn't exactly. I'm not really sure. What's going on is, if we think about it, we can make a right triangle in there. Let me use one more color here. Let's use maybe red on the bottom right there. So we have this right triangle, and the coordinates right here, use blue for that. Coordinates right here, x comma y. And let's think about what that x and y represent. The x is really just this red value down here, because it's the distance that is horizontal from the origin, right? The x-coordinate would just be whatever that red length is right there. The y-coordinate would be that purple length. Okay? So the x distance, the horizontal distance from the y-axis, and the y distance is the distance vertically from the x-axis. And the radius of this circle, because we are in the unit circle, we've talked about this, that radius is 1. So now let's use what we know about SOHCAHTOA to be able to try to kind of figure this out. So our cosine value, I'll use red for that, you'll see why in a second. Cosine of theta, adjacent over hypotenuse, that's x over 1, which is just x. So the x-coordinate is the cosine of theta. And then the y, bet you can guess. So sine theta is going to be y over 1, opposite of our hypotenuse, which is just y. So the coordinates we have up here are actually just cosine theta, comma, sine theta. And that's pretty cool. So that means any angle on the unit circle, so any angle theta on the unit circle has coordinates cosine theta, comma, sine theta. I'm going to put an exclamation point after that because I think that's pretty cool. So like if you had an angle like to this point right here. Okay, so theta comes all the way around to here. So in that case, it looks like theta would be almost 270 degrees. Maybe it's 4 pi over 3. But the coordinates here would be cosine of theta, comma, sine theta. That's pretty nifty. So any point that you have on here, positive, negative, whatever, the coordinates there will be the cosine of that angle theta that gets you there and sine of that angle theta that gets you there as well. So now we have to figure out what these values actually are. First, we're going to do a couple examples of compass point problems. So, for example, if we want to do like cosine of 0. So cosine of 0, what that's telling me is they want me to use the angle 0, which is right here. We haven't moved up at all. So it's like pi over 6 is here. We're at 0. We haven't moved at all. Cosine of 0. Cosine means I want the x-coordinate. Well, the coordinates here are 1, comma 0. So the x-coordinate is 1. So cosine of 0 is equal to 1. All right, let's try sine of 3 pi over 2. So 3 pi over 2, I believe that's the bottom of the circle, right? You could think about it as 9 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 puts us at the bottom. The sine there is going to be the y-coordinate. Cosine is always x, sine is always y. So the y-coordinate here, we're at 0, negative 1. So it looks like the y-coordinate is negative 1. So sine of 3 pi over 2 is equal to negative 1. That's all there is to it. Let's do one more. Cosine of pi over 2. So pi over 2 is at the top of the circle right there. And the coordinates there are 0, 1. Cosine is the x-coordinate, so it's 0. So all cosine and sine are asking for are the x-coordinate or the y-coordinate. Cosine always corresponds to x, and sine always corresponds to y, because we have this idea of this right triangle hiding inside the unit circle. So cosine is defined as the x-coordinate of the unit circle. Sine of theta is defined as the y-coordinate on the unit circle. So now we're going to get the rest of those points, because right now, basically, we know the coordinates at the compass points, right? We know this is 1, 0. We know this guy's 0, 1. This is negative 1, 0. This is 0, negative 1. We're going to get those last, guess what, 12 points that we need by using some special triangles. So first we're going to talk about a 45, 45, 90 triangle. So if we try to find, I've been using red for this, so I'll go back to red. So if we go to the 45-degree angle, or pi over 4, let's get that triangle in there that's hiding. We use the same colors we did before. So we use purple here, we use red here, and really I should make that hypotenuse blue. So let's do that, because that's what we did before. So what we're trying to figure out is what is the length of the x-coordinate, what is the length of the y-coordinate, because that theta down there is pi over 4 or 45 degrees. Either way you want to think about it, that guy's 1 right there. So we talked about some special triangles yesterday, and the one that had 45, 45, 90 had a ratio of 1, 1, and root 2. Now we have to use the idea of similar triangles here, because I don't want this hypotenuse to be root 2, I want it to be 1. So what we're going to do is we're going to divide all of these sides of this triangle by the square root of 2. What that's going to do is it's going to make it a little bit smaller. It's going to make it fit perfectly into here. So my hypotenuse is now 1. And these two lengths are going to be 1 divided by root 2 and 1 divided by root 2. But we don't like roots in the denominator, so you're going to multiply by root 2 on the top and on the bottom. And both of those are going to be root 2 over 2. So what we've just found is the legs of this triangle. So that red value is root 2 over 2, and that purple value also root 2 over 2. So what this means is that the cosine, which is the x-coordinate, so cosine of pi over 4 is root 2 over 2, and sine is also root 2 over 2. Because those two lengths have to be the same, which makes sense. 45, 45, 90 right triangle. So we have the legs are the same value on both legs of the triangle. So this actually kind of opens up our world, because that's going to be the same for each of what I kind of call the corners of the unit circle, right? Each of those 4 pi over 4 values is going to have this, this relationship of root 2 over 2's. All that's going to happen is some of them are going to be negative. So let's do that. So let's find the corners here. So we'll go back to using red for these. So the coordinates here we just found, root 2 over 2 and root 2 over 2. So what do you think they're going to be here at 3 pi over 4? Well, the x is going to be negative, because we're in the second quadrant now. So in the second quadrant, x's are negatives, y's are positive. Down here, what do you think it's going to be? Okay, both going to be negative. And in the fourth quadrant, we got a positive x and a negative y. So the pi over 4 is really easy. If you ever have like sine of 5 pi over 4, something like that, I just think, okay, 1, 3, 5. I want the y coordinate, so it's negative root 2 over 2. Guessing you guys have seen this before, but good to kind of refresh it and maybe see it in a little bit different way. So now that we've got the corners, we still have to deal with, let's see if we can get somewhere where I have it. We still have to deal with the pi over 6's and the pi over 3's. So the 90's are all easy, right? The 90's are all easy because they're all just like zeros and ones. The pi over 4's, those all give us some kind of root 2 over 2. Now we have to deal with these pi over 6's and the pi over 3's. So for this guy, let's draw in our axes again. And let's just kind of start with the simplest one right here at pi over 6. So we're at pi over 6 here. Once again, we want to know what is the length of the y-coordinate right there in purple, and what is the length of the x-coordinate right there in red. Got a right triangle there. And our radius, of course, is still 1, because it's the unit circle. And so we have our theta right there, pi over 6, or 30 degrees. So this, since it's 30 degrees, is a 30, 60, 90 right triangle. Get our colors right here. Red on the bottom. Oop, didn't change. Red on the bottom and purple on the side. So, we talked about a 30, 60, 90 right triangle yesterday. And we said it had a ratio of 1 to 2 to root 3. But once again, we don't want a hypotenuse of 2. We want a hypotenuse of 1. So what do we have to do? We've got to divide everything by 2. So now we have a 1. And then our red value there is not going to be root 3. It's going to be root 3 over 2. And our purple value is going to be 1/2. So what does this mean? That means our y-coordinate here, our coordinates, so the x-coordinate, keep changing colors, it's going to be root 3 over 2. And our y-coordinate, 1/2. So what does that mean? That means cosine of pi over 6. Cosine of pi over 6 is root 3 over 2. And sine of pi over 6 is 1/2 because of those coordinates that we have right there. Now this basically gives us the rest of the circle, because if we want this value over here at 5 pi over 6, well, all that's going to happen there are my coordinates, my x is going to be negative, right? Negative root 3 over 2, and then positive 1/2. Down here, we would have negative root 3 over 2 and negative 1/2. Over here, we would have positive root 3 over 2 and negative 1/2. So using this right here, I guess if we wanted to find like cosine of, I don't know, 7 pi over 6. 1, 2, 3, 4, 5, 6, 7. That's this guy right here, cosine, negative root 3 over 2. And the great thing about this is really, it also gives us the pi over 3. So we draw these axes in, all these guys. So we know this guy has coordinates root 3 over 2 and then 1/2. And this guy up here is still a 30, 60, 90 triangle. All that happened is that it got turned up on its side. So what do you think the coordinates are right there? All that happens is these switch. So it's 1/2 and then root 3 over 2. So just taking this triangle, turning it up on its side, because now this is the 30, this is the 60, and this is the 90, as opposed to here we have 30, 60, 90. So all that happened was we turned the triangle on its side, so the coordinates switch. So what do you think they are here? It's going to be negative 1/2. We're just flipping it over from here to this side, right? Should be a mirror image if I had drawn it, right? And then root 3 over 2. This guy here, we knew that from the last slide. It's negative root 3 over 2 and 1/2. This guy here is negative root 3 over 2 and negative 1/2. Then this guy down here, this guy just flipped straight over. So it's negative 1/2 and then negative root 3 over 2. This guy right here will be positive 1/2 and negative root 3 over 2. And then this guy right here is going to be root 3 over 2 and negative 1/2. So what I would encourage you to do now, we've done sine and cosine for every value on the circle. I would use the unit circle you have. Some people like to color code it different ways, but you're going to want to mark the coordinates for each one of those points and start looking at that once or twice a day just to kind of start familiarizing yourself with these values. But again, I'm going to go through how I do this for every point. I don't have them memorized. I just like to think kind of about what's going on with each point. So let's talk about how I find values here. So just as an example, let's say I was going to do cosine of, I don't know, 5 pi over 3. Okay, so first thing I'm going to do is I'm going to find the value. So find the radian value. Right, and this is the steps we talked about. So if I think about the circle here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi over 6 right here. So 10 pi over 6 is 5 pi over 3, same thing. So it's just beyond 270, or just beyond 3 pi over 2 at the bottom there. Now, I'm going to say, what do I want? So what do I want? Well, I want cosine, which is the x-coordinate. Now, at this point, it's kind of weird to think about, okay, what is the x-coordinate and what is the y-coordinate? But it's not that hard. Sine and cosine really don't have very many values that you can take, right? We've talked about all of them now. So we talked about the compass point first. Those were either 0 or 1. We had the root 2 over 2. And then we had the 30, 60, 90, which got us root 3 over 2 and 1/2. So I actually think about, for this, a number line. So I go from the smallest value to the biggest value. And all I do is I think here, like, as you go up here, what happens is the sine values increase and the cosine decrease. So right here we start at 1, 0. Cosine decreases until we get up here to 0, 1, and sine is going up. So the smallest it can be is 0. The biggest it can be is 1, right? Because we're confined to the circle. The biggest the x-coordinate can be is 1. The biggest the y-coordinate can be is 1. As we go up, so if you think about like the sine value here is 1/2. and then it gets a little bit bigger to root 2 over 2, and then it gets even bigger to root 3 over 2. Root 2 over 2, those only happen at the pi over 4s. Okay? So if you have a pi over 4, it's going to be some kind of root 2 over 2. The 1/2 and the root 3 over 2 happen at the points like this. And all I remember is which one is bigger. So looking at this, is this tiny x-coordinate or this long y-coordinate going to be bigger? Well, the y-coordinate is for sure bigger, and it's down, so that's negative root 3 over 2. The x-coordinate, the horizontal one here, is shorter, so that's going to be positive 1/2 because it's on the right. I want cosine, which is the x-coordinate, so it's 1/2. Let's try another one over here where I've got some space. Let's say, I don't know, sine of, let's do sine of 2 pi over 3. So 2 pi over 3, that's 4 pi over 6. So I go 1, 2, 3, 4. It's right here. Sine is the y value. That is the longer of the two values, and it's up, so it's positive. That's root 3 over 2. Now this takes some practice. Starting next week, we're actually going to have you guys do some unit circle quizzes, which not for speed, just to make sure that you're able to find these values. And I do this every time. I actually take my pen and I think in my head, and I'll show you this in class because it's hard to show on the screen here. But I take my pen and I actually count, and I think if I move my pen, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And wherever I have to stop, I think which one's bigger, the x or the y coordinate? X or the y coordinate, and is it positive or negative, and that's how I get these values. Not too bad. So let's actually try a few examples. If you want to pause the video and try them yourself, you're welcome to do so, and then I'll do them with you. We'll see how you did. All right, let's see how you did. So 4 pi over 3, that's 8 pi over 6. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 8 is down here. The y is the bigger coordinate down there because we're going all the way down, and it's negative, so it's negative root 3 over 2. The next one, 5 pi over 4. The pi over 4s are those special ones. 1, 3, 5 pi over 4. X and y are both negative there, so it's going to be negative root 2 over 2. Cosine of pi, pi is over here. Cosine's the x-coordinate, that's negative 1. Negative 2 pi over 3. So 2 is 4 pi over 6, so we go 1, 2, 3, 4. I'm going down because it's negative. The cosine value there is the short one, and it's negative because it's on the left, so it's going to be negative 1/2. Sine of 5 pi over 6, 1, 2, 3, 4, 5 is right there. So 5 pi over 6. The sign there is the short value, and it's positive because it's up, so it's 1/2. Cosine of 5 pi over 6, same spot, but now it's the x-coordinate, which is the long value to the left, so it's going to be negative root 3 over 2. Sine of negative 5 pi over 3, that's 10 pi over 6, down because it's negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right up there. Sine is the y value, so that's going to be root 3 over 2. Sine of negative pi and positive pi get to the same place. Up or down gets you to the same place, halfway around. The y-coordinate there is 0. All right, well, hopefully this was helpful. It's a little on the longer end, but hopefully we'll be able to talk about this a little bit more in class and figure out some of these unit circle values. Your homework tonight is the pink sheet that hopefully you got from the sub. Got some time to work on that, and that'll be due tomorrow, so I'll check that in class tomorrow. Love you guys. That's why I'm here. Have a great day.